So this is the interface of our Echo Alert dashboard and mobile application. Echo Alert is designed to detect emergency situations in real time and immediately inform authorities. In this demonstration, we will test the different types of events it can identify using live audio input. First, we begin with scream detection. As you can see, the system instantly detects the event. The alert appears on the dashboard, and you can clearly view the recorded video clip along with the exact location where the incident occurred. This allows quick verification and faster response. Next, we test gunshot detection. Again, the system successfully identifies the sound and triggers an alert in real time. The event is logged, and the corresponding video and location details are updated on both the dashboard and the mobile application. Finally, we simulate a car crash event. Once again, the system detects the incident without delay. The alert is generated, the video is captured, and the location is displayed, showing how Echo Alert can respond to different types of dangerous situations. Now, let's understand how this works. Echo Alert is always active and continuously listens to the surrounding environment. However, it does not store or record normal audio, ensuring user privacy at all times. It only processes the sound in real time to identify important patterns. At the core of the system, we use a machine learning model called YAMNet, along with a custom-trained model. These models analyze sound using MEL spectrograms. MEL spectrograms convert audio signals into visual graph-like representations. This helps the computer understand sound patterns more effectively than using raw audio files, leading to more accurate predictions. When a critical sound is detected, the system immediately sends the event data to the dashboard, along with the recorded video clip and location information. The technology stack that makes this possible includes a Raspberry Pi 4 connected with a microphone and camera, which acts as the edge device responsible for capturing and processing audio in real time. For development, we use Python, JavaScript, React, and React Native. YAMNet and our custom-trained model power the AI and machine learning capabilities of the system. We use Firebase as the backend, which stores all the event logs coming from the Raspberry Pi and syncs them to both the dashboard and the mobile app. Cloudinary is used to upload and stream the detected event videos so they can be viewed instantly. For the front end, we built the dashboard using React and Tailwind CSS. Google Maps is integrated for location tracking, and Recharts is used to visualize system activity and data. The use cases for Echo Alert include schools, public places, roads, parking areas, and smart city environments where early detection of emergencies can significantly improve response time and safety.